right. Now, it's never a good idea to reinstall software an hour before your presentation, but who would do that? But I was all set to go on this laptop and plugged it in, and it didn't want to work with the projector. And I was here a bit early, so okay, I've got time, and so quick reinstall, get everything going. I think it's going to work. There might be some surprises along the way. We'll find out. It will be good. Okay, yeah, well, welcome again, and just for the recording again, my name's David Gardiner. I'm a .NET developer, help run the user group, and just lately I've been doing a bit of work with Azure Functions, and so I thought it might be interesting to do a bit of a talk about what's new in Azure Functions. We've had presentations before. We had Sam Fernando present to the group probably about 1.5 years ago, maybe 2 years ago. You might remember that talk. I think that was the one where he was mobbed by fans at the front all wanting selfies. So if you're at that talk, then hopefully this adds and builds onto that. If you weren't, we'll give a bit of a quick recap so that you sort of understand where we're coming from. So first of all, sorry for a minute, let me... All good. Why do we care about Azure Functions in the first place? What's the use of them? So Azure Functions are, I guess, the Microsoft Azure's serverless offering, and so they're really good at running some kind of custom logic in response to some kind of event, and that could be a HTTP request that's sent to it, or it could be something else like you've written a file to blob storage, or you've made a change in your Cosmos DB database. You've sent a message into a Azure Service Bus message queue, or you've written something to a storage queue. So, and there's other things as well that can be a trigger that an Azure function can listen to and respond to. The nice thing about an Azure function is that we can scale it to meet demand. So unlike having to spin up another server, if Azure realizes that your function is getting a lot of use, it'll spin up more instances, and you can set a maximum of that. And that's all behind the scenes. You don't need to worry about that. It actually supports multiple languages. So I'm going to be talking about .NET tonight, obviously, but it also supports Java, TypeScript and JavaScript running on Node, Python, PowerShell. I think that's all. We'll find out a bit later if I've missed one there. So there's sort of multiple language support as well. And there's also some different pricing and feature plans. So the cheapest option is what I'm using for the demo tonight, but you might need some of the features that come with some of the more expensive plans, or you might not, and you can stay on the cheaper one. Just depends what your requirements are. I'm not going to drill into those differences tonight. I'm more interested in sort of what enhancements have come along in the last year or so. So just a quick refresh. So Azure Functions with .NET 3.1, which have sort of been out for probably a year or two now, I think, maybe even a bit longer. They run within an Azure function host. So we've got this process, and inside that process, it's going to spin up our class library and run our custom logic. So an event triggers the Azure function, and it calls into our code and does whatever we want it to do, and then the response goes back or wherever it needs to go to. So it seems pretty simple, and it is. So just a quick demo. We're going to create an Azure function with .NET 3.1. And to do that, I'm just going to go to the portal. So this is the Azure portal, and I'm going to go create, and I'm just going to type in func and the function app, hit create, and so I've got my subscription, I've got my resource group already set up. I need to give it a name, and that needs to be globally unique, and that one is okay. I then get a choice, do I want it run in a container or not? Well, I don't for this demo. Then I choose my runtime stack. So there's some of the other options I could choose. I'm going to choose .NET and version 3.1. and then the region I want it to run in, I'll choose Australia South East, which I think is in Melbourne. Then I can choose the storage account, and the general rule is each function host, you have a separate storage account for that. I can choose to run on Linux or Windows. There are some differences in the capabilities of those two platforms for Azure Functions. I'll stick with Windows for now, and I can choose the plan type. So there's 3 different plans there. I'll stick with the consumption one, which is the cheapest one. I can then choose, do I want app insights so that I can monitor my function, and if there's any errors, figure out what's going on, or track the performance, and then tags, and then create. And I could go through that process. So I can do all that from within the portal. The other thing I can do is in Visual Studio, I can create a new function app. So here's 2022, if you haven't seen it before. And actually, I'll just to prove it is, I will. So Devin, I haven't got my, no. I didn't plan to do this. Let's select the platform. And, oh yeah, 64-bit, okay. So Visual Studio running is a 64-bit process, so I don't know, what is the address space of a 64-bit application? Really big, I think. I honestly don't know, but it's like massive compared to a 32-bit, which is about 3.5 gig, and it would start to fall over. You could never quite get to the 4 gig. Okay, so I go File, New Project, and give it a second to think about it. And hopefully, if I type in, I've got an Azure Functions project type here. Give it a name. That's probably not where I want it. And then I get an extra window here where I can choose, I want a .NET Core 3, and I can actually then choose what kind of trigger I want to add as my first function in my Azure Function application. So you'll see there's a whole lot of different ones there. The HTTP one is one we're going to have a look at tonight, but there's blob storage, service bus, SendGrid, Kafka, RabbitMQ, all kinds of stuff there. I can hit trigger, and we can also choose what kind of authentication. So is this a public API that we're happy for anyone in the world to call, or do we want to have some control over who's allowed to call it? I could just say anonymous. Hit create, and it should create the project. Now, and yeah, it's going to work. That's good. I did do this afternoon, and that actually hung, so I'm pretty pleased that that worked. And so there we've got our .NET 3.1 Azure function. This is just a HTTP trigger. It's going to handle a GET or a POST, and it's just going to do some output. So I could even run that by pressing F5. I'm just going to run it locally. I'm not going to deploy this to Azure. And that's just launched the local emulator, and I think I've got something else running. Let me just jump down to my terminal. Yeah. Obviously can't have two things running on the same port. There we go, that's better. So that function is starting. And so it's kind of hard to read that green, but I'm just going to select that, go back to my browser, and just query that, and we've just got some text, and that's actually the text that we would have seen in the code. And actually I think it's telling me, if I go back here and pass in a parameter in the query string, then it's going to say hello David, and I'm pretty happy with that. Sorry if your name is not David, but I'm sure it would say hello to you as well if I typed your name in, but I haven't got time to do Okay, so that's a really simple .NET 3.1 Azure function. So we can do it in Visual Studio. We could also do it in VS Code. We can also do it from the command line. So there's the Azure Functions core tools, which I've got installed as well, and I can use the func command line tool and create a new project and then add triggers using the command line. We'll see that a little bit later in the talk. Okay. So, okay, that's all good. So what can go wrong? Assembly conflicts. Let me demonstrate what I mean by that. We'll go back to Visual Studio and I'll load up my project that I prepared earlier. So I've got another project here. It's written in with .NET 3.1. It also has a trigger there. And we'll just have it's got a few other things different here. We've got another trigger here, the HTTP trigger, but this is just demonstrating we don't have to have a static class. We can just have a regular class, and we can use dependency injection to indicate what our dependencies are for this class. So in this case, I'm requesting a HTTP client and a logger. And there's my method that's going to be the endpoint for the function. So the request is coming in, and this is actually going to call out to a public URL that already exists. It's actually one I wrote a few years ago, and it grabs the current weather forecast from the Bureau and then reformats that as a JSON format. I actually did that because I've got this little handset at home, a phone, a VoIP phone, and it's got a tiny little screen, and so I wanted to format the weather forecast to fit on that screen. So, yeah, that still works to this day, even though I don't know that you can buy those handsets anymore, but I just figured out it could accept an RSS feed, so if I formatted the text in that way, it would work. So this is coming back as JSON, and then I'm deserializing that using the JSON.NET serializer code. And I'm grabbing out the title that comes back from that weather. So I can run this locally, and that should work, and it should return the name Adelaide when I run that function. So I'll just wait for that to spin up. Copy that URL. So one thing to be aware of is that even if I've set these functions to be authenticated, when I'm running them locally, it just ignores that. And so there we go, the weather title is Adelaide, which is what I would expect. I probably should have actually included the forecast, but then knowing the weather outside, you might not have come. So I'll just stick with the title. Okay, so that worked, but I'll stop that. If I go back to my project file, I've added a reference here to newtonsoft.json version 13.01. If I actually use some code in this function, and I've got it commented out at the moment, I'll uncomment that. And I happen to know that this code is using a feature of JSON.NET version 13. This is going to compile, and it's going to, but we'll see what happens when we actually exercise this function now. So it compiled it, we're running the function, we'll go and call that endpoint, so I'll just press F5, and no response. What happened? If I go back to my console, there's a whole bit of red down there, and it said, couldn't find Newtonsoft version 12, but hang on, I said I want version 13. What's going on there? Well, if you remember back to that slide earlier where I showed you the host process, and it's running that code inside the same process, the problem is the host has already got its own requirement to use JSON.NET version 12. So it's already loaded that assembly. So even though we've said I want a different version, I can't, because you can't have two different versions of an assembly loaded in the same process in .NET Core. So I've got a problem there. So the current model won't let me do that. So if I'm trying to bring in a new version of something that the Azure Function host has already got in memory, I'm out of luck. There's no way around that. So that's been a current limitation of the current process. So bring on .NET 5. So in .NET 5, they made an architectural change where they've separated out the Azure Function host from the Azure Function worker process. And so now our code is running over here on the right as a separate executable in its own process. And so now we've got the freedom to load in whatever assemblies we need, and they're not going to conflict with any that the host needs. So that's one nice advantage. And we'll see some more differences as well as we go in. So let's have a look at creating a .NET 5 Azure function. How do we do that? Well, let's go to the portal. And in fact, I've got that there, so we'll just go back. Okay, and we'll try and create a 5 one, and it's not there. So we can't use the portal. It's just not supported. It's kind of annoying. So don't do that. But if we go to Visual Studio and go File, actually I'll stop that, that's still running. File, New Project, and I want to create an Azure function, and create. And yes, we do have .NET 5 here. You will notice that that little list changed slightly. So there's some of the other options here, some of the other triggers aren't supported in .NET 5. So that's something to be aware of, that there's not all the features are fully supported. But we could go ahead and create it through Visual Studio. We could also use the command line tooling to create a .NET 5 function. So I've done that already. So we'll just cancel out of that and load my project again. And we'll have a look at some of the differences between the 3.1 and the 5.0 project. So just before we move on to the 5, just some other things in the 3.1 project. I also had a service bus queue trigger, so listening to an Azure service bus. And so that's that function there. It's got a message type here. We've got an iLogger there as well. And we've implemented a startup function. So we had that other trigger, the injected trigger, and so it required the HTTP client. So I've got a startup class here that inherits from function startup, and then I'm registering that I'm also in the container for dependency injection that I need to supply the HTTP client. So I've added that as a dependency. If we jump over to .NET 5, first of all, our trigger is a little bit different. So just to refresh your memory, the trigger in .NET 3.1, it returned an iAction result, and we're passing in a HTTP request type. In .NET 5, a HTTP trigger returns HTTP response data, and it accepts the HTTP request data. So the signatures have changed between those two versions. So don't just merely upgrade your .NET 3.1 Azure function to 5 and think everything's just going to compile, particularly if you've got HTTP triggers. You're going to have to make some changes there in the way they behave. And we also get this function context passed in as well, which we didn't have in 3.1. So here I've got my deserialization, and I'm sending my response back out. We've also got our service bus trigger here, and again there's a slight change. You could do this same kind of syntax in 3.1. You could just say, yeah, I'm expecting a string. But if I wanted to use that message type, it's not there. And if I even do a control dot, it says, I don't know what that type is. Instead, the type has changed. And if you need to use that sort of approach, then use service bus received message. And that's in a different type space, namespace as well. So if we jump back to the older version, which was that one, then that message was under the Microsoft.azure.servicebus namespace, and now we're in the Azure.messaging.servicebus. So things have changed around there. But yeah, so there's some changes there. So if you're using those kind of triggers, watch out for that. The other thing that's changed is in .NET 5, rather than having that startup class that inherits, we've got a proper program class with a main method. So if you've done any work on .NET Core web applications, so ASP.NET, you'll be familiar with this kind of approach that we're generating an exe essentially. It's not just a class library. We're spinning up our host builder. We can do our registrations here in this class. So this is a little bit more familiar sort of approach rather than having some special class we need to inherit from a base class. So if we wanted to add in our HTTP client, we would do that here. If we wanted to customize our logging or introduce other middleware, we could do that here. And this should always work. So I will set that as my startup project. Press F5. Trying to think I've actually done this before. The first time you run a function, you might see this kind of prompt, just because it's going to be listening on a port. And okay, so that's running. Oops. Now this is, I can't actually run this in the browser easily because it's only accepting a post, but I can do that from the command line. And okay, this is where I wasn't quite prepared. Let's have a go. What could go wrong? So I could go invoke REST method, and that's the URL. I want the method. Let's bring this up a bit higher. To be a post. And the body, actually I don't know if I need a body out of the box. Let's try that. It does want that name, okay. Now you can see we can debug our functions in Visual Studio too. All right, so we'll provide our body. And that needs to be JSON, so I'll do that. I think that'll work. Actually, is that running? What did I miss? No, that worked. It returned. It returned. So there is a double quote. It's just the line in the screen. Sorry, I'll move it away. Sorry, yes, the crease is hiding. Yep. So yeah, that worked. I got my response back sort of down the bottom there. Okay, that worked nicely. Okay. Stop that one. Yeah, I forgot to mention too that because we're using .NET 5, we can of course use our C#9 language features as well if we needed to. I didn't really need to in that example. Some other things to watch out for. I've mentioned the change of signatures for the service bus triggers. Durable functions. It's not something I've actually had any experience with, but if you've got the requirement to orchestrate a whole lot of stuff going on and need to manage state between your functions, then that's when durable functions come in. They're supported with .NET 3.1, they're not supported in .NET 5. So if you're using them at the moment, leave them on .NET 3.1. We'll talk a bit more about it very soon as to where they can go next. And we've seen limited support in Azure Portal. It's probably also worth showing, if I jump back to the portal, I've got an existing .NET 5 function here that's been deployed to Azure. So in .NET 3.1, you can go into the functions and see what functions are provided by this application. If I go to the trigger and I go to code and test, it should have a sound effect that goes when it loads. We can't look at this function because it's .NET 5. So editing .NET 5 functions is not supported in the portal. So just do it locally. If it was a 3.1, I could actually go in and I could test that function interactively in the portal. But I don't get to do that with .NET 5. Okay, so that's .NET 5. There's some things we can do we couldn't do before, but there's also some limitations. .NET 6 is coming out in November this year. And I guess it builds on what .NET 5 can do already. It is a preview, it's not supported, so if you play with it, then you're on your own. But obviously if you find a problem, then go ahead and report that and let them know, and maybe they can fix it by the time they launch. You do need to install a version 4 preview of the core tools. And so in order not to mess up my machine, I actually used the subsystem for Linux and installed all the tools on there for the .NET 6 preview stuff. And again, because I've only switched laptops this afternoon, I hope that this should work, but we'll find out. Interestingly, we can run in process or isolated. So .NET 3.1 was in process, .NET 5 was isolated, .NET 6 is going to offer both options. And because of that, it will support durable functions as well. So that's all sounding pretty encouraging. If you want to have a play around with it, then that link will take you to the wiki page, which guides you through all the manual steps you need to do to get all the bits installed to work with this. It's a little bit, well, it's not too hard if you can follow instructions, but it's not as simple as file new project at the moment. And here's just a bit of a visual of where things are heading. So we're sort of here right now, and we've got .NET 5, .NET 6 coming out later this year, and the durable functions is the sort of the double circle thing there. And if I'm reading this diagram correctly, this is a Microsoft diagram, I didn't create it. It sort of looks like things tend to converge eventually with .NET 7 and .NET 8. So it sounds like things will sort of all come together next year, the year after. So assuming that they continue this yearly cadence of .NET releases, I guess you assume that .NET 7 will come out November 22 and .NET 8 23. But I mean, that's years away, so who knows? Anything could change by then. But also note .NET 6 LTS, long-term support. So .NET 5, not long-term support. So that's all something to bear in mind. So they're also adopting this 2-year sort of long-term support, not long-term support. So .NET 5 has got some new features, but it's not going to be supported long-term. Whereas come November, we'll have .NET 6 that will be long-term support. That's probably a better one to jump on board if you're going to make the move. Or if you're on .NET 5, you probably want to shift over to .NET 6 pretty quickly. Okay, all right. Before I go too further, I will show you the .NET 6 projects that I've got. Okay, so I've got .NET 6, I've got 2 projects, got the in process and out of process. Let's have a quick look at those. And so here's my trigger. We have a look at this and we look at the code, and actually that looks really similar to the .NET 3.1 trigger. We've got the iAction result as our return type, HTTP request coming in. So this is the in process version. So that looks like, actually, if this is the way it's going to be, probably you could upgrade your .NET 3.1 to a .NET 6 in process with little drama. And just to show that it is .NET 6, I've got some C# 10 feature usage here. In that I'm not actually using this code, but it is compiling. So I've got constant interpolated strings, and I've also got a record struct. So just to prove that it is actually .NET 6 and it's C# 10 in this project. And the service bus trigger also looks really similar to the 3.1, whereas the out of process, we look at that one, our trigger, we've got HTTP response data, HTTP request data, this is all sounding pretty similar to .NET 5, and likewise we could do the same thing with our message received type, whatever it was. So both of those are supported. Now to run those, I'm going to jump over to my console, because you do need to have that version 4 preview of the core tools installed. And I'll jump back into WSL. So I'll run the in-process one first, and I've got the core tools. So I've got this func command line tool installed. So I'll just show that is version 4. So that's a preview version. And if I go func start, that's essentially what Visual Studio is doing when I press F5. So it's just doing a build, and then it's launching that function. And because I'm in terminal, I can actually right-click on that URL, go back to my browser, and there's my Azure Function .NET 6 in process. So that's working, that's good. Stop that one. And I'll do the same for the outer process as well. Start that one up. And it's running, it's the same URL, so I'll just press F5 in my browser, and now we've got outer process is running as well. So in my case, a very simple example, so it worked. I was pretty happy with that. I'll just stop that. Okay, so we've got our .NET 5 or .NET 6 preview function running. We might even have a .NET 3.1 function. And we want to add some OpenAPI support to that Azure function. So first of all, what is OpenAPI? Well, if you've heard of Swagger, this is sort of like the standardized name for Swagger. So it's providing a definition of our REST endpoint that we can then use to document what it's doing as far as what inputs it expects and what output it provides. But also we can use that to generate a client proxy that's going to talk to that endpoint as well. So we can make sure we're passing in the right types. So if you've got an existing Azure function, we can add a package called Microsoft.azure.webjobs.extensions.openapi. It's easier to type than to say. And then add in some attributes, and that'll start to expose that as generate the Swagger document for us. Or if we're starting from scratch, and you might have even noticed this when we're in Visual Studio, there is the option to generate a HTTP trigger with OpenAPI support, and it'll add all those things for you, just with some placeholder text. But let's have a look at what's involved in doing that. So I'll jump back to my Visual Studio instance, and I'm actually going to switch branches. Let's hope this works. All right, so I've got a separate branch with this on it already. Now, the package, the OpenAPI extension package, is actively being worked on. It's actually still in preview. So if you do install it, you'll need to tick the box, say, yeah, I want to install a preview version. And the current version that's out there at the moment, I think it's 0.7.1, doesn't support .NET 5 projects, but they're working on that even as we speak. So that the current code that's in the repo for that package does support .NET 5. So I pulled that down, built a local copy, and I'm going to demo that now because I think that's probably going to get released pretty soon. So I think it's worth showing you that because a few of the names of the attributes have changed and the way things work. So bear that in mind. So I'm going to jump back to my .NET 5 project, and we're going to have a look at our trigger. And we'll see we've got a few more attributes here than what we did last time. I'll give Visual Studio a chance to figure out stuff. Oh. And I built that on that laptop. Okay. That's annoying. Okay, so I've now discovered one thing that is not going to work. I'll talk about, this is why we've got the red squiggles, because it's trying to load stuff that's not on this laptop. Maybe after the talk I'll figure out a way to copy them across and we'll demonstrate that. So essentially we've got API operation attribute, which allows us to define the operation ID for the function, which is like an OpenID terminology, a tag. Then we can provide a summary and a description. So that's an opportunity for you to document what this Azure function is doing. We can then say, okay, for the request, if it's a post kind of function, then we're going to have a body that's going to be passed in. In this case, we're expecting a JSON type, and it's going to be mapping to this particular class that I've defined here, info request. If I drill into that and have a look at that type, we'll see some more attributes. Inside the class, I've got for each property, name, age, and nullable string, I've got OpenAPI property attributes and adding descriptions for each of those. I'm also indicating for some of these whether they're nullable fields or not. And you might think, well, hang on, we've got the ability to do that in code already. Like we've got, we can put the question mark on a string to say it's nullable or not. Why can't it figure that out? It's really because of backwards compatibility. They want this still to work with the older .NET 3.1 pre-nullable reference types. So instead, we set that through an attribute property here. We can also use data annotations. So the max length and range, we can indicate, and that's going to be propagated through to the Swagger document as well. We've also got this other attribute up here called OpenAPI example, and that's referring to another class. We have a look at that. And this is a way of providing sample data in your Swagger document. So we're actually, the interesting thing here, we're just newing up an instance of that class and setting some example values for that class. And so then that's going to be displayed in the UI when we spin up this. And I don't think I can. That's really messed up my talk. If we go back to the trigger, so we've done our requests, and now we can also indicate what responses we should be able to expect from this function. So hopefully most of the time we're going to get a 200 OK, and then we're going to get some, in this case, this function is going to return some text. So it's text/plain. Or we might have some error conditions or other response codes that we might want to document. In this case, I've said, well, yeah, sometimes we might return a 400 because you forgot to pass in the body, which is what I did when I did that demo earlier. So 400 is an expected value to come back from this function. And with all that in place, we should be able to then run this and see the Swagger. So what I will do as a workaround is we'll go File, New Project, Function, and yep. And we're going to choose with OpenAPI and hit Create. Okay, this should pull down. Just waiting for Visual Studio to respond. There we go. Yep, okay, so that's pulled down the public current release version of that package. That should all build. Yep, so I should be able to press F5. That'll run that function. And we should see some extra endpoints listed here. So as well as our function, we've also got some other endpoints here. So I'll select the Swagger UI endpoint, copy that, jump over to my browser. That's not my browser. And paste it in. And we should see our, if you've used Swagger before or OpenAPI, this should look pretty familiar. So we've got our UI here. We can expand that endpoint. We've got our name and our description. And this is where, if we had some example data, that would appear here as well. So the example that they provided is pretty simple. Okay, here's where it gets interesting, because I want to show you. You'll notice that we're currently generating, I don't even think it says a version at the moment. So there's our Swagger document. It's just sort of a JSON document there. You could read that if you want to, but it's something normally you would pass through to some kind of tool to deal with. Okay, now we're going to do something that I hadn't planned to do, which is, so what I want to do is customize some of that metadata, and I want to actually change it so that it's generating a version 3 of the OpenAPI document. So to do that, I'm going to add a class, and it doesn't really matter what it's called, but I will grab a copy of it out of, yes, I trust. That's what we were talking about earlier in Visual Studio Code. And this is what I want. So my normal demo would have just uncommented that, but that's not going to work. So let's add that class and paste that and uncomment that. And fix up some namespaces. And okay, let me just check. Okay, it looks like they've changed some implementations here. Let me grab that. And put that in there. Actually, I think that might work. I'm just going to clear these ones out. I know this is very exciting to watch, but bear with me. And let's see what that does. Okay, let's go back to our browser. Okay. I'm not going to persist with this too long. Oh, did I lose that? Let's try that. No, okay. If you're interested in that demo, come and have a look at the other laptop where it does work. Sorry about that. Okay, what I should be able to do essentially is customize the extra metadata that's showing there in the Swagger document, and you'll see that represented in here. The other thing you would be able to see is the nullability being represented in the Swagger document there as well, if we'd set that up properly. Okay. All right, so quickly summarising that, using those attributes against our function and also any types that our function is using, sort of expecting to come into that function or going out, we can then generate that Swagger document through the OpenAPI package. All right, so we've got our function running, we've got our OpenAPI. How can we deploy this? Well, we could right-click deploy in Visual Studio, and you might do that once, and indeed that's one way to get your .NET 5 Azure function configured properly. You can go into Visual Studio and deploy it from in there, and it'll set up the Azure function correctly for running .NET 5. You might also want to use Azure Pipelines, and so I'll quickly show that. And so our Azure Pipeline, we're using YAML for that, and we've basically got two stages in our build. We've got our build stage where we're pulling in the 3 SDKs in our case. We've got 3.1, 5 and 6 preview, because I'm going to build all those different Azure functions that are using those different SDKs. And just to note, if you're building a .NET 5 Azure function, you still need the 3.1 SDK installed as well. I then do a build, and I'm going to use the .NET publish command, and I'm just zipping up the publish directory, and that's a build artifact. And then my deploy stage, it grabs those artifacts from the previous stage and then pushes those through the Azure Function App task. And I've already set up an Azure service connection in my pipeline so that I can then just pass that through here. That was what the GUID was up the top there. And so then it's got permission to talk to my Azure subscription and the resources in there. And in this example, I'm just deploying the .NET 3.1 and .NET 5 functions. And that'll push those out. So I'm not going to run that right now because it takes a few minutes and that wouldn't be very exciting to watch. But I will jump into my Azure DevOps subscription. So here is a deploy I did on Monday. We've got our 2 stages. We've got our build stage, which generated the 2 artifacts, and then our deploy stage. And we can see it does take a few seconds to push each function up. And that all worked, which is good. For the same repository, I've also got GitHub Actions set up. So this pipeline I've set not to trigger automatically, because otherwise I have 2 things trying to deploy Azure Functions at the same time. That's probably not a recipe for success. So in my case, I've let the GitHub Actions be what's going to get deployed. So we'll have a look at the action. It looks kind of similar. If you've never seen GitHub Actions before, you'll think, gee, that looks a bit like the Azure Pipelines that you just showed me before. You can certainly see they sort of come from a similar heritage. And also just a plug for Aaron Powell, whose blog post is a good step through this process for setting up GitHub Actions as well. So again, we're pulling down the 3 .NET SDKs, 3.1, 5 and 6 preview. We're then running .NET Publish. It's got some directory listing stuff there. Then I've got my grabbing the output of each of those published directories. And so in this case, I'm for all 4 functions, the 3.1, 5, 6 in process and 6 isolated out of process. And then we go down to our deploy. And so then we're going to grab those artifacts from the previous stage, and then we're deploying all those 4 functions up to Azure. Now, important thing to note here, if you are writing an Azure GitHub Action workflow and you want to use this functions action here, the latest version is version 1.4. And there's a bug in that release. You can still deploy, but it'll take about 3 minutes per function because there's something going on where it tries and fails, and then gives up. That bug is not present in the previous version, 1.3.2, so just bear that in mind. Hopefully they fix it soon. It's been reported and lots of people are seeing it, so you'd like to think that someone's working on it. But yeah, that can be the difference between a deploy of about 30 seconds versus a deploy of about 2 or 3 minutes per function, which can be a bit of annoying. So that we can jump over to our GitHub repo and jump in there and see the last time that ran, and that was yesterday. So we've got our 2 jobs there, the build and deploy, and they all ran. So most of those are taking just sort of about 40, 50 seconds. For some reason, this one took a little bit longer. I don't know why. But yeah, they all got pushed out. So just to demonstrate that all those functions are actually running, all of those have got an Azure Service Bus trigger in them. And so what I'm going to do is, well, first of all, go back into Azure, and that's okay. We'll go down to the Service Bus and drill into, so Service Buses can have queues and topics are when you want a message to be able to be sent to multiple subscribers. So I've set up a topic, and my topic is called Of Conversation. So, which previously when I was just using a queue, my queue name was called Cumber. So anyway, it amused me, if no one else. And so I've got 4 subscribers and basically 1 subscription per Azure function down the bottom here. I don't know if you can all see that. And actually, that is kind of funny that the .NET 5.1 has still got a message there. That makes me think it's not happy. Okay, I'm going to go in, and I've got a console application here, .NET Run, and that's going to send a message to that service bus. Woo! Actually, I can run this over here. Just pretend that worked. And I'm going to do exactly the same thing, I promise, on this laptop. The reason it's not working is I haven't set up the config file on that laptop. I could do that, but I know it will work over here. Just waiting for it to get back to me. This laptop is recording stuff, so it's kind of busy. There we go. All right. Wow. This laptop is really under load at the moment. Okay, so that is running. I think it's going to take a few seconds to do anything. I'll tell you when I get a response. So what I'm expecting is, as soon as I hear back from that command being finished, I'm going to refresh, and I'm expecting to see some other messages appear here in the queue, and then they should drop away. Okay, message sent, good. So refresh, and there we go. So there's an extra message in each subscription, and then, assuming all those functions are working, and I'm suspecting the .NET 5.1 is not, the fact that there's one left over from when I tested this earlier. If I refresh again, then I should see those messages drop away over time. Now, I am sure that because it knows I'm doing a presentation in front of a large crowd, it's not going to do it for me, but...
well, I have the cold boot from Azure Function when it's not currently running with my consumption plan is sometimes 20-30 seconds.
Yeah, so... Yeah, now Ryan raises a good point that if you've got requirements around the performance of your function, then some of those other plans might be better choices. Obviously, I'm a cheapskate, so I chose the cheapest one, and so that does mean that things can go to sleep, and they can also take a while to spin up again if they have gone to sleep. I'll get it one more time. Hey, there we go. So my .NET 3.1 trigger fired and processed that message, and so now there's no more messages for that one to do. One more time. Hey, another one. So that my outer process .NET 6 worked. Maybe and there we go. I think that .NET 5, that's gone down to 1. So yeah. That's most curious that there's a message still there. Oh. No, I don't think so. We'll look at that later on. Anyway, just to prove that all those functions were deployed into Azure and they're all running. They're not doing anything exciting, but they're all running. That's the main thing. Okay, so wrapping up. So we saw a demo of being able to use .NET 5 and even .NET 6 in preview for Azure Functions. We saw being able to add OpenAPI to your function, and if you want to see a bit more of that, come down here and I'll demonstrate that a bit more, adding in that metadata on the other laptop. And we also set up some CI/CD pipelines so that we can build and deploy our functions into wherever they need to go, so in Azure, obviously. Further reading, I've got the link to my repo that I use for the demos for tonight's talk. There's also a README there that I've linked to a whole lot of other resources there for further reading around the different packages that you'll need when you're dealing with Azure Functions. So that's sort of the end of my talk. Is there any questions anyone's got around Azure Functions, .NET 5 or 6? Ryan.
So this was probably old information now, but I heard that they're not planning to officially release .NET 5 functions as general availability. It was just going to be an eternal preview until .NET 6 came out. Is that changed, or is that still the case?
As far as I know, .NET 5 functions, well, yeah, I guess we haven't seen them supported in the portal, and we're not seeing that the support of like the durable functions and those kind of things. So I don't know anything specific to answer the question of is .NET 5 supported. But well, my understanding is it is supported in as much as .NET, it is available and it is running, but .NET 5 itself is not an LTS release of .NET. So I don't know. I mean, it's a good question. Like, will .NET 5 continue to be supported in Azure in a year's time? Like when .NET 5 is out of support? There is, I can't remember what it is exactly, but there is like when .NET 6 is released, then I think that's the time starts ticking for when .NET 5 stops being supported. It's usually pretty quick, I think, too. Yeah, I guess there's certainly support avenues, whether that's an official Microsoft support ticket or it's through the GitHub repos where you can raise an issue there and try and get some help. Yeah, no, good question. Yeah. Any other questions? No, that's cool. Well, thanks for your attention. Feel free to come down here. I'll stop the recording and see if I can demo the other OpenAPI example on the other laptop. Help yourself to Subways. Someone open that box of swag and help yourself to the O'Reilly swag in that box over there on the table. Thanks for checking in as well, and we'll see you all next month. Thank you.